predictive analytics. We are doing the prediction. And predictive analytics is one of the business analytics, all right? For this one, we do the time series forecasting. That is, we use the time series. So what is a time series? So a time series is a series of data points that we collected at successive points in time. For example, we collect the data every hour, every day, every week, every month, or every quarter, every year. And what we do is that we will use the observed data in the past to predict the values in the future. So for this time series forecasting, we will have only one variable, and we typically give the variable name the y. So we only have one variable, y, and we have the previously observed data, which is our past data or our data set that we collected at successive points in time. And we use that to predict the future value of the y. When we do the time series forecasting, it's better to extract or detect the pattern in the time series, because there are a lot of methods that we can use for the forecasting. And with the patterns, we will be able to choose better method that will give us higher accuracy. All right. So there are 5 common types of pattern that can exhibit in the data set or in the time series. The first one is the horizontal. So for the horizontal one, you will see that the data fluctuated up and down, but then there will be some kind of a constant line here that we can draw like this, and this is the constant mean. Here, constant mean, that is, if we take the average, we kind of get this mean here, and the data points kind of fluctuated around this mean. So this data has a horizontal pattern. For this, the horizontal pattern can shift from this level to this level. And we call this like a new normal, like before COVID and after COVID. Here, before COVID, the sales might be around this point. After COVID, the sale might be around this point. So this still a horizontal pattern, but the mean just shift higher, or sometimes the mean might shift lower. It depends on the new normal. The next pattern is the trend pattern. For this one, the values of the data points just gradually increasing or gradually decreasing over time. So it's gradually go up, 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 and up. So this is the trend pattern. We can draw a trend line that can either in a curve or a straight line like this, gradually going up, gradually going down. So this is a trend pattern. Here, the next one is seasonal pattern. Here we have data points, and we can see there are recurring patterns, meaning there are the same patterns that recur or occur at the fixed time period. So for example, the seasonality is from here to here and here to here. So this composed of like 4 seasons in 1 year, and each point is 1 quarter. The pattern is that the quarter 1 start here and it goes up to quarter 2, go down to quarter 3, and go down more to quarter 4. And then that pattern typically occurs in 1 calendar year. Once a year is over, the next year starts. Quarter 1 is here, and then quarter 2, the sale goes up. Then quarter 3, the sale goes down, and quarter 4 go down even more. And again, the next year, the data repeat here, go up, then go down, and go down, and so on. So this has seasonality or seasonal pattern. The next pattern is the data series that has both trend and seasonal. For here you can see that there are season or there are patterns like this one pattern, and then it recurs next year and then again and again. But each seasonality, the data points kind of gradually increasing. So this one not only has the seasonal pattern, but it also has the trend pattern that the data increasingly going up and going up. Focus on the previous 4 patterns. And the last one is the cyclical pattern. So for this one, you need a lot of data in order to see the cycle. This we call the cycle. And the cycle, one cycle can vary. For example, this one, the data span for like 20 years, from 1975 to 1995, 30 years. And the one cycle is like this. So this is one cycle. And then the next cycle is this. And then the next one is this. You can see they are similar cycles, but the length of each cycle can vary, all right? Or this one also contains kind of like 3 cycles too. This is like one cycle here, another cycle here, and then another cycle here. For this class, you don't have to worry about this cyclical pattern because it's kind of very difficult to detect and very difficult to predict. So you will just so you know that there is another cyclical pattern. And typically we call it the business cycle. That happens every 10 or 15 or 20 years. Briefly. So once we detect the pattern, then we can choose the forecasting methods. There are 3 groups of methods that we can use. The first one is the simple ones. For this one, we don't need to know the pattern, meaning this method can be applied to any time series with any patterns. The first method is, in this group, is the naive forecasting method. For the naive one, we just use the recent data point to forecast for the next time period. So for example, if we are at the time period 1, t equal to 1, week 1, then if we want to forecast for the time period 2, we will just use the data from time period 1 to be a forecast for time period 2. And this is the simple y hat, meaning this is the forecast. And this is the y, that is the actual data. So here 17 is our y hat 2. And y hat 2 is from y1. We are at time 1, we use it to forecast for the time 2. And then for time 2, we use the actual value of time 2 to be a forecast for time 3, and so on. This is the naive one. So once we have the forecast, one thing that we have to check is the performance or the accuracy of the forecast method. We measure the accuracy in terms of error that the model produces. The error we will start measuring the error for each time t. So ET is the error at time t. So for the naive one, we have y hat, and we start at y hat 2, that is 17. We have y equal to 21. This is at time 2. So here E2 equal to 21 minus 17. This is from 21 minus 17. And then E3 equal to 19 minus 21, and so on. All right? And then you can see that the error has some of them are negative, some of them are positive. If we just take the summation, then the numbers will cancel each other out. That is not what we want. So the first one is to use the absolute, take the absolute of that error, or the second method is to take the square. And that is the reason why we have two measures, mean absolute error and the mean square error. You can choose either one of them. What we want to do is to convert the negative errors to be positive error. That is, from negative number to positive number. There are two ways that we can do that. So if you choose the mean absolute error here, then for each ET that can be positive or negative, you put in the absolute so that the negative 2 can be converted to positive 2. And every error now are positive, and then you can calculate the average of the error. And that is the MAE. For the MSE, the mean square error, so instead of taking the absolute, here you will take the square. Again, the error will be square, all the numbers are positive, then you can calculate the average for this one too. And this is the MSE. Recap. And okay, for the simple forecasting method, there is another method that is called an average forecasting method. For this one, sometimes we call it all average forecasting method, meaning that we will use all of the data point up until that period, average them, and use that to be a forecast for the next period. For example, if we are at time T1, the forecast for time T2 will be just the T1, no need to average, right? But then at time T2, then you will forecast for the Y hat 3. So now you will use these two numbers, all of the data point up until that point, average the number, and you get the forecast for time T3. And again, if you want to forecast for the time 4, then you calculate the average of the data point from time 3, 2, and 1, and so on. And this is the all average, okay? And that is what we covered last week. So now let's continue. All right. But for those of you who haven't watched yet, because it's kind of like on Friday and then it's Saturday and Sunday, and today is Monday, so I understand that you might have something else on the weekend. So let's see another two methods that we can use. This group is called smoothing method. Here, this one, it is particular appropriate for time series that have a horizontal pattern. So if you have time series and you can detect horizontal pattern, it's better to use these two methods because it will give you higher accuracy than the previous two. And here, the first method in this group is called moving average. And the second one is called exponential smoothing. So these two, the objective is to smooth out, to make the time series smoother. So here, this is the original data points. You can see that it has high fluctuation, right? And sometimes we don't like that in our data set. We don't like, variation. So we try to get the forecasting line in the black line here that is smoother than the actual data points. And we will use this black line as our forecast line. So let's see how we can construct that, the black line that is smoother than the actual lines. Let's see the first method here. It's the moving average. The moving average is kind of similar to the all average. That is, we will take some data points in the history, calculate the average, and use that as a forecast. But for the moving average, we will just use the most recent K data points, average them, and use that to be a forecast for the next period. So for example, if we want to use this method and we say that we have to specify the K, how many number of data points that we will want to use. Let's say K equal to 3, all right? And if you want to forecast for time period 6, all right, for time period 6, then, and you will be at time period 5. You are at time 5, you want to predict for the time 6, so it's like the next time period, right? This is from y hat 5 plus 1, right? Where t equal to 5. Here, because you are at time 5, so now in order to predict the value at time 6, you will use the actual data point at time 5 plus at time 4 plus at time 3. And we stop here because the K equal to 3, meaning we will use only 3 data points. And to get the average, you just divide that number by 3. Again, if you are at time 6, then you will want to predict for the value at time 7, right? And we will use the data point from time 6, time 5, time 4 divided by 3. Okay? And this is the reason behind this formula. You actually don't need to remember the formula, but if you want to, here the formula is like this. So here we can write down y hat t plus 1 equal to the summation of the y. We call it the summation of the y, where y equal to t minus k plus 1 up until t. So for example, if t equal to 5, so if t equal to 5, we will just plug in the t equal to 5 here. Y hat 5 plus 1, which is y hat 6, right? Equal to the summation of the I, where I start from t equal to 5, k equal to 3 plus 1 up until the value t, which is 5, all right? And then let's just summarize this number from I equal to 3 to 5, right? 5 minus 3 plus 1, yi. And then you start to plug in the value of I into this subscription. So here, the summation here, I have to divide it by k. And then here we plug in the value of I, start at 3, it increase by 1, 3, 4, and 5. So we start at y3. The summation is the plus y4 plus y5, and we stop here because this is the maximum value of the I. And then we divide it by k. And now what is the value of k? 3. So it's the same. Just another way to do this to understand the formula. So either use this one by your understanding, or you either use this one by the mathematical way, up to you. Okay, so let's see an example. This is the weekly time series from week 1 to week 12 of the gasoline sales time series. Here we will use the moving average forecasting method, and the number of data point, the k equal to 3. We have t for the week 1, week 2, week 3. We have the actual data point, and then we want to calculate the forecast, the y hat. So, because k equal to 3, we need at least 3 data points to calculate the forecast. So the first data point that we can make a forecast is time k plus 1, that is the time 4, right? So, oh no, I mean at the time k. So here, at the time t equal to 3, you want to forecast for the forecast for the time 4. And in order to get the y hat for the time 4, you use the most recent k values. The k here is 3, right? Use the most recent k value, average, and then you will get this number here. At time 3, you forecast for the time 4. And then at time 4, you forecast for the time 5, right? So this is the time 5 here. So when you are at time 4, you will use the most recent 3 values. Starting at that point, calculate the average, and then use it as a forecast for time 5. Again, if you are at time 5, then you will predict for the time 6. Okay, so this is the time 6:20. Here, because you are at time 5, you will use the data from time 5, and we go back for 3 data points, calculate the average, and you will get the y hat for time 6. So you can see that the average is moving. That's why it's called moving average. And the time frame is the same, that is 3 data points. Good? Okay. I hope, well, this is fun. Moving, keep moving. All right, so next, here. So once you have the y hat, the forecast, here we can actually plot plot the actual y, here the actual data points versus the forecast values. And the blue one is the actual data point, and the black one is the forecast one. So you might wonder why we want to forecast these data points when we already have this actual data. It's actually we use this actual data and get the forecast to check the accuracy of that model. So we can be sure that even with the data in the past, something that we know the answer, right? So we can check that the model can give the forecast that is close to the actual value. Before we use that for the future, right? So we need to check with the actual data that we have before we use that to predict the data for next year. So for example, here, let's say we are at time 12. Like right now, it's at the end of time 12, and you want to forecast for the time 13 next week. Then you have to make sure that this model here is accurate enough for you to use in order to actually forecast for the next time period. So that's why we want to check if this actual value and the forecast values are close enough, all right? Okay. And that is how you measure the accuracy. You can either calculate MAE or calculate the MSE. And I will not go in detail of the 2 measures anymore. So basically you will have the Y, you will have the Y hat, you calculate the error at time t. If you want the MAE, A is from the absolute, so you calculate the absolute of the error. If you want the MSE, S is from square, so you take the error square, and then you just calculate the average of the error square or the absolute error, up to you, depending on what measurement you use. Alright, that is one method that we can smooth out the data. So the next method that is the same concept is called exponential smoothing. For this one, we will only use two values to estimate to calculate the forecast. So for the forecast at time t plus 1, you will use the actual data at time t and the forecast value at time t. For example, if we are at time 4 and we want to calculate y hat 5, that is the forecast for the next time period, then it will be equal to the alpha time y4. That is, you are at the time 4, so you use the actual data at time 4 plus 1 minus alpha time the y hat at time 4. And this is the exponential smoothing. The alpha is called smoothing constant, and the alpha can be from 0 to 1. Okay? Typically, we set the alpha from around like 0.1 or 0.2 or 0.3. Okay, so let's see an example. This is the same data set, the gasoline time series. We have y, we have the t, and we want to calculate the forecast, the y hat. Now we are going to use the smoothing constant, exponential smoothing with the alpha equal to 0.2. So let's write down the general equation with the alpha equal to 0.2. So here we can write down the equation as y hat at time t plus 1 equal to 0.2 time yt plus, this is 0.2, 1 minus 0.2 is 0.8 time y hat t. Alright? And this is the general equation. And so now, we can start at time t1. For time t1, again, we don't have y hat 1. So we're gonna use the actual y to be a forecast for time 2. So this is y hat 2. We just simply use the y1. So y hat 2 equal to y1. So now, if we are at time 2, we want to forecast for time 3, right? So let's write down the y hat 3 equal to what? 0.2 time y, what number? 2, yes. Plus 0.8 time y hat 2 again, yes. So, here we are at time 2. And we want to forecast for time 3, the next period. We all just need the data available at that time to forecast. So, y2 equal to 21. Y hat 2 equal to 17. So we just plug that in. 0.2 times y2, which is 21, plus 0.8 times y hat 2, and y hat 2 is 17, and then you should get 17.8 for y hat 3. And we can do the same for y hat 4. So here this is y hat 4. So for y hat 4 we are at time 3. Right? At time 3 we want to forecast for time 4, the next period. So here again we write down the general equation. 0.2 times y3 plus 0.8 times y hat 3, yes. And now you just take the y3, that is 19, 0.2 times 19 plus 0.8 times y hat t 17.8, and then you should get 18.04 for the y hat 4. Good? Alright, so that is how you calculate the forecast using the exponential smoothing technique. And for this one, the line, the forecast line here is smoother than the average, the moving average one. So now let's practice. We are using the same time series, the gasoline sales time series. And here, you will have to calculate the MAE from two methods. So the first one, you will use the moving average method with the K equal to 6. Calculate the forecast for the moving average method using K equal to 6, and then calculate the MAE from that one. And then again, for the next question, use the exponential smoothing method with the alpha equal to 0.3, and then calculate the MAE. And then the last question, now you will have 3 models, okay? The first one is the moving average with K equal to 3. That is the one in the example that I just showed you. And then with the K equal to 6, that is from the question 1. And another method is from the exponential smoothing from the question 2. Compare them, compare the performance of the 3 methods, and choose the one that performs the best with the reason why that method performs the best. Alright, I will give you probably 20 minutes for this one because you need more time for 3 questions. Wrap up your work, clear your head for more information, for more fun. Okay, let's come back. So now let's go to the last group of method that we can use for forecasting. And this one we're gonna use the regression model. Here for regression model, we will use them for the time series that have a trend pattern, seasonal pattern, or trend and seasonal pattern. So again, if your time series has these 3 patterns, you should use a regression model for that. Okay. Let's see the first one. If your time series has only trend pattern like this, so this is the bicycle sale. The blue line is the actual bicycle sales, and the black one is the trend line. So here we will use a simple regression model for trend line. So when you see simple, it means we will use only one predictor in our model. And this is the model that we will use to calculate the y hat for this time series that has trend pattern. In this case, the equation here will use t as the predictor. T is the time period. The time period depending on the data set. It starts from time period 1, 2, 3, and so on. But the actual meaning of each time period can be different. The time period can be daily, can be weekly, can be monthly, but the time period will be like 1 point for each data point. So let's see an example. So here you have this data cell, the sales time series. It's yearly sale, okay, from year 1 to year 10. So we have time period T equal to 1 until t equal to 10. So here our time period is the year, and it starts at t equal to 1, and we have the y1 here. And we have until y10. And now we will use Excel, put in the year and the sales, and have the Excel calculate the regression model for us, and we get this equation back. So in order to forecast for y hat t, it's equal to 20.4 plus 1.1 times t. So for example, if you want to forecast for year 9 is here, the time period is 9, t equal to 9. You just plug in the number 9 for the t, and you get the y hat 9 equal to 30.3. Alright, this is the simple regression model for time series that has trend pattern. The last data point that we have is year 10, right? If we want to predict for the next 3 years, it means we want to predict for t equal to 11, 12, and 13. That is t equal to 11, 12, and 13. So now for each one, and if you want to forecast further, for example, you want to forecast for the next 3 years. Here, for example, for t equal to 11, you want to get y hat 11, the forecast for time 11. You just plug in the value equal to 11 in the equation. That is the general equation in this case. Again, is y hat t equal to 20.4 plus 1.1 times the value of t, right? Again, t equal to 12, we want to forecast the y hat 12. We replace the t with the 12, and we get the y hat 12. For t equal to 13, it's going to be the same, y hat 13, plug in the number t equal to 13, and then you get this number. Good? Okay, so back. Next, let's see the seasonal pattern. So this data set has seasonal pattern, and for the time series that has seasonal pattern, we will use a multiple regression model, and we will have to find or to count a number of seasons first in the pattern, and then we will create k minus 1 dummy variables. So you should remember the dummy variables, right, from the Friday session. Okay, so here, once you see that, okay, this time series has seasonal pattern, you will have to extract one pattern in the data set, in the time series. So here, again, this pattern contains 4 data points, all right, from time period 1, 2, 3, and 4. And then the next pattern occurs right here, 1, 2, 3, and 4. And then again, the next pattern, 1, 2, 3, 4. And if you continue, it's going to be the same 1, 2, 3, and 4. Yes. And then, let me check. Okay, here, this is one pattern, seasonal pattern. It has 4 points, meaning it has 4 seasons. So in the seasonal pattern, each point will be 1 season. So here there are 4 points in the pattern, so there are 4 seasons. Once we have the number of seasons, here, so now the number of seasons will be the value of the k. So here, k equal to 4. We have 4 seasons. we need k minus 1 dummy variable. And in that case, 4 minus 1 equal to 3. We need 3 dummy variables. Alright? Here, if you go, it's the umbrella cell, so each one is the quarter 1, quarter 2, quarter 3, and quarter 4 for each year. So now, so for this data set, each time period is actually the quarter. So we have 4 quarters per pattern. So now we are going to create 3 dummy variables, alright? And if you remember the concept of dummy variable, we first have to pick the reference value, right? So here we have 4 seasons, and the value is the quarter 1. Let me write it down like quarter 2, quarter 3, and quarter 4. Let's pick the reference value to be quarter 4. Alright? So the reference value will be quarter 4. So when we pick the reference value to be quarter 4, it means there will be no dummy variable that represent that value. Alright? So we have 3 dummy variables. We name it QTR1, QTR2, and QTR3. The QTR1 represents quarter 1. So QTR1 equal to 1 if the time period is in quarter 1. It will be 0 otherwise. QTR2 represents quarter 2. So again, QTR2 will be 1 if the time period T is in quarter 2. It will be 0 otherwise. QTR3 represents quarter 3 again. It will be 1 if the time period is in quarter 3. And there will be no dummy variable that represents the quarter 4 because it is the reference value. Alright? So now, let's see how we convert the original data in quarter 1, 2, 3, and 4 into this dummy variable. That we have 3 dummy variables for 4 seasons. So here, if the data or the time period is in quarter 1, then the QTR1 will be 1. Other QTR will be 0. Again, if the time period is in quarter 2, QTR2 will be 1. Other dummy variables will be 0. If quarter is 3, again, QTR3 will be 1. Other dummy variables will be 0. And the last one, quarter 4, which is our reference value, then all the value of the dummy variables will be 0. And now we convert this actual data quarter 1, 2, 3, and 4 into 3 dummy variables. And then we can put that into our data set and use the Excel to calculate this multiple regression model for us. So for this one, we will have 3 dummy variables, right? QTR1, 2, and 3. So now in the equation, we will have 3 predictors, QTR1, 2, and 3, which each coefficient for each one, B1 for QTR1, B2 for QTR2, and B3 for QTR3. And so once we define our dummy variable, we will convert this actual data into the dummy variables data. So here, the original column is the year, so we put in the year here, year 1, year 2, year 3, year 4, and year 5. We have the original quarter here. So from this original quarter here, we will convert them into 3 dummy variables, just like we do in the previous slide. So again, if it's in quarter 1, QTR1 will be 1, other will be 0. If quarter is 2, QTR2 is 1, and so on. Alright, it's the same concept. And for when we are at the year 2, we repeat the process. QTR quarter 1, QTR1 is 1, the rest will be 0, and so on. And then the last one is the cell. This is the Y, the target variable, the one that we want to predict. And we put this in our Excel, and then we will get the model. I will actually show you how you actually can do it with the Excel. So let me switch. Okay, so here this is the period from 1 to 20, and this is the dummy variable, QTR 1, 2, and 3, and this is the sales here. We want to forecast the sales using the dummy variable, QTR 1, 2, and 3. So what you have to do is you will go to this data tab, and then you will see the command data analysis. This one, you will click on that, and there will be a lot of models that you can make. For this one, we will want to make the regression. So you will go down here, regression model, click OK. Once you see this window, you will put in the range for the input Y, the one that we want to predict, that is the sales. So you go to the column sales here, drag it over, this is our Y. And then the X, we will have 3 X's, that is QTR 1, 2, and 3. So you just go there, drag over this one, including the header names. And since we also include the header names, we click on the labels, that is the data has the labels here. And just click OK. And then you get this result. And you should remember how to read this result, right? Do you? How do you construct the model from this result? So it's the Y hat, right? It's the estimate value equal to what? Okay. Let's zoom in just in case you cannot see. Y hat equal what number? What? We start with the intercept, the B0. What is B0? 95. Yes. And then plus or minus? Plus 29 times now what? We have B1 times X. X in this case is what? QTR 1. Alright? So it's the QTR 1. Right here, this is the coefficient for each one. This is the coefficient for the intercept, which is just the constant value. And then coefficient 29 for quarter 1. So you just take 29 has the plus side times the predictor QTR1, and then you go to the next coefficient, right? Then the next one is also plus what? 57 times QTR2, and then plus 26 times QTR3. And there you go, you have the model. You have to remember this. Alright? I don't want you to actually to be able to do this by yourself, but at least you should read the result. Okay? You don't have to do the data analysis, go to the regression and everything, but you have to be able to read this. Right? And so this is the model that we have. And we can use this model for the time series that have the seasonal pattern. Alright? We have data up until year 5, right? So we want to predict for year 6, the next year. Year 6, quarter 1, year 6, quarter 2, year 6, quarter 3, and year 6, quarter 4. For quarter 1, what will be the value for QTR1, QTR2, and QTR3? It's 1, 0, 0, and the 0, 1, 0, 0, 0, 1, 0, 0, 0. Alright, so you plug in for the first quarter, plug in 1, 0, 0 for the QTR 1, 2, 2. So here T stop at 20. So the next time period will be 21, 22, 23, and 24. And so let's go back to our slide here. And that is exactly this equation that we just got. Here, y hat at time t equal to 95 plus 29 times QTR1 plus 57 QTR2 plus 26 QTR3. So once we have that, we can use this equal and 3 equation to do the forecast. So this is the equation that we got from the Excel. And so here, we will want to make forecast for year 6. Because right now, here, quarter 1, year 6, quarter 1. This is QTR1, QTR2, and QTR3. So for quarter 1, QTR1 will be 1. You plug in the equation, you get y hat for the next time period, which is the time here. This is for time 21. Alright? And now year 6, quarter 2, then QTR2 will be 1. Plug it in, you get y hat 22. For year 6, quarter 3, QTR3 will be 1, and you get y hat 23. And again, for quarter 4, every dummy variable will be 0, and you get this number. And this is y hat 24 for year 6. What about year 7? Will we get the same number? Should we change anything? So if we want to predict year 7 for quarter 1 to quarter 4, you think we will get the same numbers? No? Why not? We shouldn't, right? But if we use this equation, will we get the same numbers? We will, right? Because we just changed the value of the quarter. There is no time period that we can plug in, right? So for this time series that has the seasonal pattern, we will actually just forecast 1 year ahead. If we are at year 5, we forecast for year 6. And then once we are at the end of year 6, we will forecast for year 7. And here's what you will do. So let's go back to the data set here. We have until year 5, right? Here, this is year 5, so if I put in the year here, this is year 1, year 2, year 3, year 4, year 5, right? And okay, let's make it quarter. Oh shoot. 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. Okay. So this is the original data. We have 5 years. And then we forecast for the year 6, right? And now, if we are at the end of year 6, then you should have the actual sales for year 6. You will have the sales for year 6, and the time period will be 21 to 24. The quarter will be the same, like this, and you will put in the actual sales for year 6. Let's say 135, 167. I have to respect the period, the pattern. 120 and 100. So now you are at the end of year 6. You want to forecast for year 7. You will have to make a new model because you have new data, right? You have this actual sale from year 6 that was not available at year 5. So you will just update, we call update the model. That is, you will repeat the process here, do the regression model, and here the output Y will be this cell here. And the input X will be from year 1 to year 6. And then you click OK, and then you will get a new model that you can use for year 7. Alright? And you should be able to construct the model from this one by now. Okay? You can do it. Okay, and wow, we still have the next method. Okay. Next, more fun. Now we have the time series that have both trend and seasonal. You will see that there are patterns that recur every 4 points again. So this data set has seasonal pattern, but then it's also gradually increasing. So this one have both trend and seasonal. What you just have to do is you just combine the equations. So remember the equation from the trend pattern, you have the predictor T, the time period. And the equation from the seasonal pattern, you have QTR 1, 2, and 3. And if the data set has both seasonal and trend, you just combine the 2 equations and you get this equation. Nothing new, just one more predictor. You have QTR 1, 2, and 3, and you have the time period. This one assumes that this pattern has 4 seasons. That's why you need 3 dummy variables, all right? But if your data set has different number of seasons, then you will need different number of the dummy variables. But you will always need one time period T if your data has the trend pattern. So here you will just, for this one, when we make the model, you put in the time period here as another X, with the quarter 1, 2, and 3 as the 3 axes, and then the cells as the variable Y. Let's go back. We only have the data until year 4, quarter 4. What we want to do is to make the forecast for year 5, quarter 1, 2, 3, and 4. And now, for year 5, the time period T equal to 17, 18, 19, and 20, right? The time period T stop at 16. This is the T. for t equal to 1 to 16, and what we want to predict is for year 5, time period 17, 18, 19, and 20. The quarter is 1, 2, 3, and 4. And you the same, convert each quarter to QTR 1, 2, and 3, like 1, 0, 0, 0, 1, 0, 0, 0, 1, and 0, 0, and 0. Alright? And here, let's assume that we put that in Excel and you get this equation. The general equation with the QTR 1, 2, and 3 that are for the seasonal pattern and the time period T that is for the trend pattern. So let's see, how do we make the forecast for the year 5? So again, how you plug in the numbers. So here, for year 5, quarter 1, the time period is 17. So here, T equal to 17. You put it in quarter 1, QTR1 will be 1, and QTR2 and 3 will be 0, and the T equal to 17. And then you get Y hat 17. And again, for year 5, quarter 2, that equal to time period 18, you plug in QTR1, QTR2, QTR3, and time period 18. And you get this number and so on. Good? Okay. The last problem for this chapter, not for today, for this chapter. So this is a new data set. The first task that you have to do is to extract the pattern in this data set. So the first question you have to answer, what type of pattern exhibit in this data set? Once you have that, you will use that to pick an appropriate method for that pattern. And for this one, I give you two methods or two models, A or B. You can see that for model A, it only has the dummy variables QTR1, 2, and 3. For model B, it has QTR1, 2, and 3, and also the time period T. Okay? And then you should know that this method is best for which pattern. This method is best for which pattern, and then you pick that based on the pattern that you get from question 1. Alright? You get the pattern from question 1. You use that answer from question 1 to pick the equation from question 2. And once you pick that equation, compute the value for next year. So here we have data until year 3. So what you have to compute is the forecast for year 4. That's you have to compute the data, the Y hat for year 4. Quarter 1, 2, 3, and 4. Put those 4 numbers in the answer for the second question. Good? Okay. You should finish in 15 minutes because I still have another chapter to do. Feel free to take a break first and come back, but you have to finish everything by 4:45.